Hey guys, Baju up here, and welcome to the 13th video in our Let's Learn Java series, in our 2D game programming series. And today we are going to be implementing lighting, which is a favorite from the last time I did this series. So, before I do that, I'm actually going to change some things real quick. Let me get rid of what I have here. This is some stuff I'm working on. I'm working ahead of the tutorials. I've started doing that, so that way when we get to the newer stuff, I've already coded it and I've already tested it, so that way we don't run into big problems. But what I am going to do is I am going to change our font, because we have this nice little font, right? It's the one I made. You know, I like it. But we're missing characters, and what if we wanted a bigger font? Well, you have to draw a bigger font, and drawing font takes up some time, right? You can make it nice and cool, but it takes some time. Luckily, last time I did this tutorial series on an old channel, this dude, I forget his name, but he made a font generator for me. He called his engine a J2 game. It made it for me. It's a long line of code here. It's all one class, but it'll generate a font image for you using your fonts in your computer, and it works very well. I don't remember his name though, but I will have this linked in the description. And yeah, so I'm going to show you guys how to use it real quick. You just put it into Eclipse, and I made a new project called Font Generator, and it has a class called a Font Creator. I think that's what it's called in the thing, or did I rename it? No, it's called Font Creator, and it has a lot of code. I did change one line of code just because that was here. When we were creating the sprite image, I made it an ARGB image. It was an RGB image, and where's it at? Is it right here? Yeah. So when they set the color, I set it to a new color, which is 0000. It was setting it to that magenta purple color, but because we have alpha calling, I might as well make it transparent. And there's no built-in transparent color in the color class, so I just made a new color and set it to 0000, which is transparent. So that's the only difference. So when you run this class, you can choose a font, right? And you can choose a font size, so you can make a nice big font if you want. Now, actually, what I have found to be the most useful font, oddly enough, because it translates very well, is Comic Sans. I know that might seem like heresy, but for some reason Comic Sans actually translates really well to like small font sizes. So let's do, I think 10 is a good size. So you just hit create sprite, and then we'll put it into the folder as fonts. See, I already have one here, but I'm going to replace the standard image, which is the image we currently are using. Actually, I won't do that because I mean, I have another copy of it, but I might as well keep it. So I'm going to call it comic. Why not? And there we go. It created it. And if I refresh my project, then resource, fonts, I have my comic image, which I will open in GIMP here just so you guys can see it. By the way, this is useful to do because you see how these, it looks at them like they're text files, they're images. But if you open it up in an external program with Eclipse, you can set it to always use it. This is taking it a while because it's looking at all the programs on my computer. Oh, there we go. And I'm going to use GIMP because GIMP is awesome. And I want to use this for all PNG files. So now whenever you click on those, it'll open it in GIMP. But anyways, here's the text file it generated. Now, the only problem it does have is that it makes them a little big, but I'm not sure if maybe there's some fonts where it does go down there. Because he has some code inside of his generator that adds like an extra pixel onto it, and actually has it go through each character looking for odd height characters. So I haven't really messed around with it. You can probably mess around with it to get rid of this dead space. I mean, some characters do need it, like G goes down here to 2 away. But yeah, so with this generation, you get big characters, you get lowercase characters, and you get all your symbols. Any character that doesn't actually have a symbol, like these are like space and Space, enter, return. No, space is right here. There's enter, return, control V, control C. They're all like these little symbols, which are useful, but, so yeah. Now, we have this. I'm going to implement it into my font. So font, my standard font is no longer be standard. I'm going to make it comic, right? That's a problem. There's more than 59 characters. There's 256 to be exact, which is how far he goes, which once again, you can modify the font creator to use more than 256 characters. But that'll get you everything in English and Spanish, actually. I think it gets the Spanish characters as well, the accent mark characters. All right, and so we change that, make them bigger. And then after that, we need to go to our renderer, and we no longer want to set it to uppercase, and we no longer want to subtract 32. And that's all you got to do to change it. So now when I run it, not that, run Game Manager. When I run it, hey look, we got the text, which is Comic Sans. And I know, I'm going to keep using that Comic Sans, which works very well. So like if I was to go to my game container, let's change it just to give it a test. So here is the FPS, exclamation point, smiley face, just to show it off a little bit here. So you get, here's the FPS, smiley face. All right, so you get more characters. Although the characters are a bit bigger. If you go lower than 10, it starts getting hard to read. Because, so yeah, we now have a nice new font. Let's do that. Let's have capital and lowercase. So we have FPS. Boom. All right, that's not the main goal here in this video. That took 7 minutes, but that wasn't the main goal. The main goal here was actually to implement lighting. So what is the first step to implementing lighting? Well, we need to change my render. Well, we need to add something to it. So when we render our image, I want to have an array specifically for our light color. I'm going to have an array for blocking the light. So, and normally when you do lighting, you calculate it based on vertices, but we don't have any vertices. All we have is pixel. So I'm going to calculate my shadows based off of the pixels. And since I want to be able to modify it, I don't want to just say, I need to have an array to store the data for whether or not that pixel blocks light or doesn't block light. Okay, so let's add those in. I'm going to make a private int array. I'm going to call it light map, LM. I'm going to make another array. I'm going to call it light block, LB. And I'm going to initialize these the same way as I initialize the depth buffer, which is lm equals new int array p.length. Come on Eclipse, there you go. lb is equal to new int array p.length. Boom. So now we have those arrays. Now I have a set pixel. I'm going to have a set light map specifically. So I'm going to make a public void set light map. It's going to take in a location, an int x, int y, and an int value, because we need to know what value it is. And we're going to do the same thing here, except for alpha testing. We don't care about alpha at all for lighting. So I'm not going to even calculate the alpha. So if it's just out of the array, don't render it. All right, so now we want to render it. Now we can't just say light map, light map x plus y equals, x plus y times width is equal to value. That's not exactly going to work because we need to blend the light together, right? So you have, say we have a red there and we have a greenish color. We want to blend those colors together to get what would make sense for lighting. Now, the best way to do that, I have found, is to use the maximum value of the R, G, and B as the final values. So we need to get the red, green, and blue from the two colors, and we're going to calculate which one has the max value, and we're going to take the max value from the two colors and make them into one color, and set that as the final value. And it's works the best and looks the best in my opinion. So I need to know what color is already there. So I'm going to say lm x plus y times p width. I'm going to store this actually in an int base color. Alright, so now we got our base color. And just for temporary purposes, I'm going to make an int final color. I'm going to say final color. I'm probably going to get rid of these and just straight put them into place. But I'm going to do that for now. It's equal to 0. Might as well just initialize it. Alright, so we need to know int max red, an int max green, and an int max blue. So we'll call them. Alright, so the max red is going to be equal to math.max. We need to take the max of 2 colors. And I'm just going to kind of do these all at the same time here. Boom, and boom. So now we need to get the red from the base color and the red from our value and put them in here. So how do we get the red? Well, we've already done that before where we get the red. So I'm just going to copy this, right? We already wrote it once, might as well copy and paste it. But this isn't pixel color, this is base color. And I'm going to copy this, put it here, and change it to value. Alright, and we're going to do the same thing here for all of them. I'm just going to go ahead and copy and paste them all into these arguments. And we'll change the first one to base color. And our last one's value. Right now this is all getting the red, so we need to change it. So green is 8. And blue is no color at all, so we can get rid of the parentheses and the 16 and the bit shift, because we just want to end it with that. And we might as well get rid of those outside parentheses. In programming, I'm not sure how well Java is set up to do this, but the less parentheses you have, the better it will run. Usually. I know it's true for C, but Java is a bit of a weird language. And I don't know if it gets rid of them when it compiles. We'll just do that just in case. It makes it a little faster having less unnecessary parentheses. Alright, so now we have our max value, and we're going to create it into one color, which I'm just going to copy this. We don't need this final color. I don't know why I even made it. I'm just going to paste this here. That's fine. We don't actually need to move anything over there. Same thing over here. I'm actually going to change our set pixel. We don't need that. We don't care what the alpha value is of the base. We only care about the new. So I modified the set pixel in there, just so you're aware. So this should be max red, max green, max blue. And there we go. That should set our light map properly. Now we have a light map set. We need to actually we need to merge the light map and the pixel map, right? So I'm going to do that in processing. So it's rendered all of our images, right? Now, after we render all of our images in our processing, I'm going to merge the light map and the pixel map. And the way that works is by doing simple for loop. Int I equals 0, I is less than p dot length, I plus plus. Alright, so the way we merge it is we're going to take the red, green, and blue from our color, and we're going to find out what its decimal value is by dividing by 250. So we'll get a 0 to 1 depending on how bright it is. And then we're going to multiply the pixel color, the red, green, and blue, by those values. And that will give us our final color value. Okay? I'll show you what we're going to do. So let's get our light map red. Let's do lm I, right? Here's our color. And I'm going to pull out the red, green, and blue. So let's just pull those out. 16 and 25. I'm just going to store these right now. Float red. We might rewrite this here to make it so it doesn't store. And I'm going to divide the resulting number by 255. And I'm going to do that for the red, green, and blue. And once again, blue is 8. I mean, green is 8, blue is nothing. And there we go. So now we got the red, green, and blue, and we got it as a number from 0 to 1, depending on the color. All right? And then I'm going to set P at I is equal to, now we got to create a new integer. So we're going to do the same thing where we OR our numbers together. So I'm going to take P I, I'm going to get the red out, right? Do the same thing here. I'm going to AND it with 25. You could write 255. You could write 255, but 0x FF looks cooler. All right, so we have our number, and we're going to multiply it by our red. Then we got a problem here, though, because in order to OR numbers together like this, it has to be integers. It can't do floats. So we have to then put this in parentheses, and we're going to cast it to an int. All right, so we got our first number down. Now we got to do the others. I'm going to copy and paste this for the others. Or that. All right, so move this over by 8. Multiply by green. Get rid of the move for blue. And multiply it by B. And that should give us our final answer. Actually, no, wait, we got to shift it back over. Because we're ORing these together, but we haven't shifted them back. And so after we do our math, we then have to shift it to the left, 16. Shift the green to the left, 8. And we don't need to shift the blue at all. And that should merge our two arrays together and give us a final color. Now, we don't have a light to test this with right now, so I'm going to just use an image. I'm going to just write in a render code right here. For loop int x equals 0, x is less than image dot get width x plus plus int y equals 0, y is less than image dot get height y plus plus. Yeah. Alright, so what we need to do now is I'm going to actually do r dot set light map xy is equal to image dot get a pixel, not class, x plus y times image dot get width. Alright, so now this will render a light map of image 1, which I forget what image 1 is. Very interesting result. I'm going to change image 1, which is test. So let's open up test. And I'm going to just make it basically into a light. Okay? Because we don't need this. Let's get rid of all this. Oh yeah, I have my brush. I have an airbrush, not airbrush. Why would I want an airbrush? Let's just delete it. Boom. All right, and because it doesn't matter with size. Oh geez, how big shall I make this? Let's make it a 64, right? Or is that radius? That should do it. And I'm going to make it red. It doesn't matter that it's transparent because our light map doesn't care about transparency. So if I go like that, it kind of looks like a red light. We'll go with that. And I'll overwrite test. What does test 2 look like? Once again, a transparent object. I don't want it to be transparent right now because I want to make sure that it works for non-transparent. So let's just make that white. Actually, let's just make that white. And I'm going to refresh. So what am I moving around with my mouse? I'm moving around the white with my mouse. That's fine. So here is our red image. What is up with that? There's still where is it getting that from? Oh, hang on, we're still rendering things. I don't want to render this image right now. I'm not don't care about that image. Don't care about Z depth. Okay. We still have this image in the background of what? There's no thing here. Where's it getting? I don't understand where it's getting the the texture in the background from, because it's not rendering that anywhere. It doesn't make any sense. Did I do my math wrong here? No. Hang on, something's weird. That height, line height, right? X, Y, yep. Max green. Yep. That should work. Something's being weird. But anyways, it's black, right? When there's nothing there because the background is black. It's not going to render a light if it's black. Let's actually change some things. Make my test image, right? This guy is really small. Oh yeah, we're rendering him as a tile. Let's not render him as a tile. Let's render him as an actual image so we get the whole thing. It's also completely gone for some reason. Yeah, something's a little weird here. That's weird. Because this guy disappears. He shouldn't disappear. Oh yeah. We have to do something. I forgot. We have to clear these arrays, right? We're not using the light block yet, which we will here in a bit, but we need to clear these, and we don't actually want to clear the light map to 0. 0 is pitch black, right? This is our ambient color. So I'm going to make a new private int ambient color, right? What color is what's your darkest color on your screen? And it's set to 0 right now, which is pitch black, and we don't want it to be pitch black. That's why your image doesn't render outside of the image. So I'm going to make it to like a darkish gray. That's a good gray. So that's my color. I'm going to take that hexadecimal representation. I'm going to set it equal to 0xff, and then I'm going to paste that X color there. So if I render it now, oh yeah, we can actually use it. Ambient color and light block equals 0 as well. So now when we do it, my white image is gray because that's the color. And when we come over here, we have our little image here. I still don't know where it's getting this outer layer from, because you can see it's coming up with a texture from somewhere, and I don't know where that texture is coming from. There's no texture here. What is going on? Can I just delete this layer? New. All right. I don't understand where it's getting that color from. Let's try this again. I'm gonna set the opacity low. Make it a little bit bigger. Make a new layer. Here we go, that looks good. Overwrite. Come back here. Our whole image is red. There's something up here. I don't know what. Let's try and figure this out. Okay, we got our max. We're getting our color from our value, and base color. And then we move that over. Let's system that out. Let's figure out here if this is actually giving us the proper color that we want. Let's just check our red. Shouldn't just be solid 255. That's weird. So our base color should be black, right? Our base color is our ambient color, right? And our value we're passing it is not just straight red. it's saying that the value we're giving it is 100% just red, but it's not, because if you look at our image, that is not just red. That is what? Color picker. Pick that color right there. Maybe that's why, but it shouldn't. I think it's mainly just because I have this alpha channel. Remove alpha channel. There we go. We can't have an alpha channel. That's probably what's going on. There we go. Now we're getting somewhere. And normally you don't render an image like this. Like we don't do our lighting with an image, but I'm trying to test it with the image. So it is actually working as intended. The white background should actually be black to, to more accurately represent what we want. So if I make this black and then I do the white over top, it'll give me actually what I want. That is way too red. Why is that so big? Oop. That looks more like a light. Export, play. There we go. Now we got basically a light. So there we go. Okay, I'm going to divide this up into the next episode here. And we're going to actually implement the lighting. And we're going to have shadows and all that. So, I'll see you guys next time. Comment, rate, subscribe, and thanks for watching.